Hey, M218, let's take a look at section 1.1. So one of the many topics in this section is the topic of union and intersections. I think we first need to make sure we all have the same idea of a definition. So what is an intersection? An intersection is an overlap. It could be the overlap between two sets of numbers. It could be the overlap between two segments. It could be the overlap between a segment and array. It's the overlap of two different quantities. Another way to look at intersection is to use the word both. Okay, if you have two statements, then the intersection are where both statements are true. If you have two sets of numbers, you are looking for the numbers that are in both sets. That's just basically another way of saying the overlap. Okay, maybe we use the word and. In Algebra 1, you probably said, well, where's the first statement true and the second statement true at the same exact time? Okay, so both and are kind of the same idea. You are looking for, well, what numbers are in the first set and the second set? Or where does the left segment and the right segment exist at the same exact place? Okay, in our class, I definitely need you to understand that this is the symbol that denotes an intersection. So it looks like an upside down U. Maybe mine's a little sloppy, but that is the intersection symbol. And you'll see in examples how that works. All right, switching gears to union. So if the intersection is the overlap, or if the intersection is where both statements are true, then the union is where one or the other is true. So I'm going to use the word either. Either the left statement is true or the right statement is true. Okay? Maybe it could include the intersection if there's an intersection, but there doesn't have to be an intersection. So a union can be where the first statement is true or the second statement is true. So either the first one's true or the second one's true. Any part of either statement that's true is included in the union. So for our purposes, something you will hear me say that you're not going to see in a book or anything, I will explain it probably more in class, but I usually use the phrase that a union takes everything. It takes all of the first statement, anything that makes the first statement true, and it takes anything that makes the second statement true. So typically I'll use overlap for intersection, and I will use the fact that a union takes everything. Okay, quickly before we get into an example, just make sure you understand that this is the union symbol, this is the intersection symbol. So now we need to put everything into practice and see if we can make it all work. How do we, on a number line, graph x is greater than 5 and, there's the key word, and x is less than or equal to 7? So hopefully this is relatively easy because this is straight up Algebra 1. So here's my key numbers. There's a 5 and there's a 7. Now I'm going to do some scratch work down below. First, I'm going to take a look at, well, what does it mean to be x is greater than 5? Okay, x is greater than 5 would be an open circle at 5. And it would be all the numbers to the right of 5. What does it mean to be less than or equal to 7? That would be a closed circle at 7. Okay, it's closed because we have the equal to sign there. So a closed circle at 7, and it would be all the numbers to the left. Now remember, this is an and. So an and is the intersection. Okay, it's the overlap. So where do the numbers overlap? The red and the blue overlap here from the 5 to the 7. Therefore, my final answers would be starting at 5, open circle, closed circle at 7, and all the numbers in between. So what have I done? I have graphed all the numbers that are greater than 5, and at the same exact time, the numbers have to be less than or equal to 7. Now, real quick side note, I should say that this is not just the number 6. There's numbers like 5.5 and 5.1 and 5.001 or 6.99 in that region. So it is all the numbers between 5 and 7, not including 5, but including 7. So what happens when I change things around just a little bit, but the big difference is I'm changing the and to an or. Remember, an or is a union. So let's see how the union works. First, let's go just like we did the last example. Let's do some scratch work. So if x is less than 5, what does that look like? That would be an open circle at 5, and the numbers less than 5 are to the left. Okay, second group, x is greater than 7. So what does that look like? That's an open circle at 7, and the numbers greater than 7 are the numbers to the right of 7. So now we can see each of our pieces, but we have to explore what does or mean. And or, remember, it's kind of like either or. So it's all the numbers that either make the first piece true, which is over here, or the numbers that make the second part true, which is over here. So the or takes everything. It takes both groupings, and we get a final answer that looks like this.